Okay, so this is section 6 homework. So we're doing 20 through 28, and what we're asked to do is to describe the transformations and then sketch the graph. So 20 is this, and so it's a quadratic equation. So it's either going to look something like this, or it's going to look something like that. And because the coefficient in front of the x squared term is going to be positive, it's going to go up. There is no y translation because there's no y value, there's no constant value. So all we have is just the x movement, and you always kind of like solve for x. So where x is equal to, where this term goes to 0 is where you're going to move it. So you get x minus 8 equals 0. So it's going to move 8 units positive direction. So let me get a graph paper so I can do these on a piece of graph paper. Okay, so there we are. Okay, so what we'll have is we'll have the vertex right here, and with a quadratic equation that has just a unity coefficient, you basically go over 1 and up 1, and you go over 2 and up 4 because you're squaring it. So that quickly gives you those points. So you have something that looks like that, and if you went over 3, 1, 2, 3, you'd go up 9. 3 squared is 9. (21) is a third order polynomial, x cubed plus 7. So we just have x cubed by itself, so there's no x translation. We do have a constant by itself. So, and let me write for the previous problem, let's just write it out. So it would be translate to right 8 units. Okay, up here we have translate vertically 7 units. So you have to be careful when you're doing the x translation. It's actually the negative of this number here, whereas here it's just the number by itself. So let's copy that graph over here, graph paper. So it's going to be centered around x equals 0, but we're going to move up 7 units. So 1, 2, 3, 4, 5, 6, 7. So that's where it crosses the y-axis. And for a third order polynomial, you go over 1, up 1, you go over 1, down 1. Then you go over 2, up 8, which is going to be way up here. And you go over 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's because 2 cubed is 8. 1 cubed is 1. So it looks something like that. Okay, 22. It's another cubic function. Negative x cubed minus 1. So we have a negative in front of the x cubed term. Another way you can think about this is it's really a negative, the quantity x minus 0 cubed minus 1. So this negative sign is outside the parentheses in this form. And what that tells you is you reflect across the y-axis when the negative sign is out here. Now, if you had, say, negative x quantity cubed minus 1, then you would reflect across the y-axis. But in this case, it doesn't make any difference, so we'll show that. But this is the one that we're looking at, this one right here. So there is a vertical, so let's write out what we're supposed to do here. So we're going to reflect across x-axis, translate vertically, -1. So translate vertically -1, which means go down 1. So what we can do is we'll do the actual reflection first, and then we'll do the translation. So I'm going to start at 0. So we go up 1, over 1, up 1, over 2, up 8, left 1, we go down 8. So that's what it looks like. It's pretty skinny, depending upon the scale that we use. Okay. So now if you reflect that, what happens is you come over around the x-axis, then this point here goes down there, and this point there goes down there. The one up here goes down there, and the one down there comes up there. So that is the reflection process. Like that. And then we do the translation process, which is down 1. So this red curve gets moved down 1. So we cross the y-axis here. So from this point you go over 1, down 1, and then you go over 2, down 8. And over here you could go over, starting at your crossing point, you go over 1, up 1, and then you go over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's your 5 points. You're going to cross the x-axis here, the y-axis there, and then you're going to do this. So that's the translated version. So it goes through there, and then comes down like that. Now, I said if you do this one, you get the same result. The way that one would work, let me just show you. So from that perspective, what you would do is you start out with your original parent function. So you'd go over 1, up 1, over 2, up 8, over 1, down 1, over 2, down 8. So that's my original function. Now if I reflect this, I reflect it across the y-axis. So this point goes there, and this point goes there. This point goes over there, and that point goes over there. And you end up with the same curve. So it doesn't matter in this case whether the negative side is inside or outside. You end up with the same curve. It's just one's reflected across the x-axis and one is across the y-axis, and then you'd make your vertical shift. Okay, 23. So that's f of x equals 2 minus x minus plus 5 squared. So what we have is we're going to have translate or shift, translate to right or left, because it's if we solve that, x plus 5 equals 0, you get x equals -5. So translate to left 5 units. Then reflect across x-axis, and then translate up 2 units. So that's the translation. So I'm going to put the graph over here. So the parent function is a parabola. Over 1, up 1, over 2, up 4, over 3, up 9, and then over 1, up 1, over 2 up 4, over 3 up 9. Okay, so that's my original function. I'm not going to connect together yet. Now, if I move this in the -5 direction, so I'll go 1, 2, 3, 4, 5 to here. So from this point, I can do the same thing. Over 1, up 1, over 2, up. Let me use a different color. Let's use blue. So you go over 1, up 1, over 2, up 4, over 3, up 9, symmetric the other direction, like that. Okay, so that's x plus 5 squared. Now, the next thing you do is you reflect that around the x-axis. So this point stays the same. These points go from here to here. So I actually go over 1, down 1, over 2, down 4, over 2, down 4, over 3, down 9, over 3, down 9. So you get that point. And then finally you move it up 2 units. So this is where you end up. So from this point you're going to do the same thing. It's going to go downward, so you go over 1, down 1, over 1, down 1, over 2, down 4, 1, 2, 3, 4, over 2, down 4, 1, 2, 3, 4, and then you go over 3, 1, 2, 3, down 9, 2, 7, this one's symmetric. So my ultimate curve looks something like, that. Okay, next one, 24. F of x equals negative x plus 10 squared plus 5. So the same thing, you're going to translate to left 10 units, reflect across x-axis, translate up 5 units. So again, let's start with the parent function. It starts at the origin, goes over 1, up 1, over 2, up 4, over 3, up 9, over 3, up 9. Okay, so that's my original one. Then I would move to the left 10 units. So start here, over 1, up 1, over 2, up 4, over 3, up 9, and you would go the same way here, symmetric. Then you would reflect across the x-axis. So this point would be the same because it's on the x-axis. This one would go down 1, over 1, down 1, over 2, down 4, over 3, down 9. So that's that part. And then we move up 5. So we'd go up to here. So you go 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4, 5. And then we're going to pointing downwards. So we go over 1, down 1, over 1, down 1, over 2, down 4, over 2, 3, down 9, 5, 6, 7, 8, 9. So it looks something like that. Okay, next one, 25. F of x equals x minus 1 cubed plus 2. So we're going to translate right 1 unit. We're going to translate up 2 units. and it's a cubic function. So again, we're going to start with the parent function. So you start at the origin, over 1, up 1, over 2, up 8. It'd be over 3, 27. So, okay, over 1, up, down 1. So the cubic, you go one way here and you go down the other way there. So you go like that. So that's 1 cubed, 2 cubed. Then we translate to the right 1 unit. So that's going this way. So over 1, up 1, over 1, down 1, over 2, up 8, over 2, where am I starting here? There, I'm going to make sure I know where my starting point. Over 1, down 1, over 1, over 2, down 8. Okay, so it looks kind of like that. And then finally, you're moving up 2. So we go 1, 2 to here. So that's my anchor point. And I go over 1, up 1, over 2, up 8, which is going to pull all the way up to here. This way, down 1, 2 this way, down 8, which will get me to that point. So I have my 5 points, and I can sketch this thing like that. (26) f of x equals x plus 3 quantity cubed minus 10. So again, we're going to translate left because x plus 3 equals 0. You get x equals negative 3. So that's the distance you go in the x direction, was it's left 3 units, and translate vertically 10 units down because we have a negative 10. This one's going to be a little problematic to sketch on my graph here. So again, we start off with the parent function, the cubic. You go over 1, up 1, over 2, up 8, over 1, down 1, over 2, down 8. Okay, so that's our initial function. Then we're going to move to the left 3 units, 1, 2, 3. So there's my anchor point. Over 1, up 1, over 2, up 8, over 1, down 1, over 2, down 8. So that's it translated to the left. And then we go down 10 units. So this thing goes all the way down to here. So that's my anchor point. Let me use a different color, red. So this anchor point moves down to there. And then we go over 1, up 1, over 2, up 8. So it's that one. We go over 1, down 1, down 2, 8, right down there. So it's going to look something like that. (27) f of x equals negative the absolute value of x minus 2. So we've got the absolute value function. It's going to be reflected across the x-axis because the negative sign's outside, and you've got a vertical shift of negative 2. So we're going to say reflect across x-axis, shift vertically 2 units down. So our parent function for the absolute value is just a straight line in this direction and then going up that way. So it's like y equals x, but it has this V shape to it. So the first thing we do is we reflect across the x-axis. So instead of going up, we go down like that. and then we move it 2 units vertically. So we take this and we move it 1, 2 units vertically. So we just go diagonally down like that from here. And we can draw some lines in for that because it's easy. So we go up to 2 units, have a 45-degree angle like that. And we go there and have another 45-degree angle that goes through those points like that. So that is it. And let's see what we have. 28, another absolute value function. F of x equals 6 minus the absolute value of x plus 5. So first we have a shift. Got to write shift instead of swift. Shift horizontally 5 units to the left. Okay, x plus 5 equals 0. Solve for x is negative 5, so we go negative. Reflect across x-axis and shift vertically 6 units up. So our absolute value function, our base function, is like this. First we shift it horizontally 5 units, so 1, 2, 3, 4, 5 starts there. That's my anchor point, and I go up diagonally like that. Reflect across the x-axis, so the ones that are above the x-axis go below the x-axis like that, and it goes diagonally downward. And then shift it up 6 units. So we go 1, 2, 3, 4, 5, 6. It's there. And we just follow the same. And let me use green instead. So green goes down diagonally. So our final function looks something like that right there. And that right there. Okay, moving on to the next question. This is problem number 34. So what does it say I'm supposed to do? Oh, it's just a continuation of what we were doing. So we have f of x equals the square root of 4, or x plus 4 plus 8x. So this is a square root function. So we have to do our parent function. So the translation, so we're going to shift left 4 units. Again, x plus 4 equals 0. Solve for x, you get x minus 4. So we go negative 4. And then we shift vertically. And we go up 8 units. Okay. So what is a square root function? Well, it's like x squared, but it's kind of the opposite. So you start at the origin. The other difference is there is no negative. You don't have anything less than 0 when you have the standard f of x equals the square root of x. So what you do is you go, instead of over 1 up 1, you go up 1 over 1. Instead of going over 2 up 4, you go up 2 over 4. And then you'd go up 3 over 9. So that's 1 squared, 2 squared, 3 squared. So that is my parent function. Like that. The first one is to shift left 4 units. So we go 1, 2, 3, 4. So there's our anchor point. Up 1 over 1, up 2 over 4, up 3 over 9. So there we go. So that's the next one. And then vertically 8 units. So we go 1, 2, 3, up here to 8. So there we start. Up 1 over 1, up 2 over 4, and then we go up 3 over 9. Should put us right about there. So that is the result. (36) f of x equals negative the square root of x plus 1 minus 6. So we're going to have a shift to the left 1 unit. X plus 1 equals 0. Solve for x, you get x is negative 1, so you go negative 1. We're going to reflect across x-axis because of this negative sign. And we're going to shift vertically, and we're going to go down negative 6, or down 6 units. I don't need to do negative because that's just a repeated. Okay. Again, our parent function starts at 0. It goes over 1, up 1, over 2, up 1 over 1, up 2 over 4, up 3 over 9. Okay, so those are points. We're going to shift to the left 1 unit. So we're going to move the anchor point, and then we're going to go up 1 over 1, up 2 over 4, up 3 over 9. So you can see everything's been shifted to the left 1 unit. Now we're going to reflect across the x-axis, so that one stays the same. So I'm just going to put a red point over that. That one goes down here. That one goes there. So we go down 3 below. So that is this part. And then we go down 6 units. So we'll go 1, 2, 3, 4, 5, 6. So there's my anchor point, and then I go down 1 over 1, down 2 over 4, and down 3 and over 9. And so my final function is going to look like that. Now, this is not one of the ones, none of these have the negative sign inside. And so I want to go ahead and talk about that. Maybe they talk about it in the next section, but I don't think so. So we looked at that earlier for another example, but let's say we had f of x equals the square root of negative x plus 3 plus 4. So the negative sign's inside the parentheses. Now the question is, do you move? We know we reflect around the y-axis, but do we go to the left or right? Well, anytime you have a negative sign inside the actual base function, the parent function, you factor out that negative sign. So if I factor out a negative sign from both of these, I'll get negative x minus 3. Negative the quantity x minus 3, which if I apply that negative sign here to there, you'll get back to where we started. So what we have is we have a shift in, and actually it's easier to do the reflection first in this case, especially when you have the negative sign. It's not you can't do it the other way, but so reflection around the y-axis, and we're going to shift in. We're going to shift. So again, set this equal to 0. So you get x minus 3 equals 0, means x equals positive 3, so shift right 3 units, and then shift positive 4, so up 4 units. So the way this would work is your parent function is going to start here. It's up 1 over 1, up 2 over 4, up 3 over 9. We're going to reflect across the y-axis. So what will happen is this point, instead of going down here, is going to go over here. And this one, instead of going to the right 4 units, you go to the left 4 units. And this one, instead of going to the right 9 units, you go to the left 9 units. So that is just negative the square root of x. Now, we're going to then move 3 units to the right. So we take our anchor point here, go 1, 2, 3, so that's right there. And then we go up 1 over 1 to the left, up 2 over 4 to the left, and up 3 over 9 to there. So those are my 4 points. And then finally I go up 4 units. 1, 2, 3, 4. And you can see all I have to do is shift all those points up by 4 units. Like that. So these are all 4 units higher than the previous one. So your function looks something like that. And I'm going to prove this is right just by using the graphing program to show that it works. So the function I just did was, and you're missing part of this because of the way I've got the screen set up recording it, but it was equal to the square root of negative x plus 3 and then plus 4. So I think that was the original function. Square root of negative x plus 3 plus 4, okay. So we push graph, and there it is. I need to zoom out a little bit, but you can see it's up 4 units, it's to the right 3 units, it's going in that direction. So let me just, well, you can see that that's what we have. Okay, what's next? 38. So 38 is f of x equals the square root of 3x plus 1. So how do we handle this? Because we have a non-1 unity coefficient in front of the x term. So that's either going to stretch it or shrink it in the x direction. It's going to be centered around the x, around the origin from the x perspective. So let's try this. So the parent function is just the square root of x. So you start here and you go over 1, up 1 over 1, up 2 over 4, up 3 over 9. Okay. Now, does this stretch it or shrink it? Well, it's kind of opposite of what you would think, in that when you have a larger number here, you actually, the coefficient here is the square root of 3. So you have the square root of 3 times the square root of x. And the square root of 3 is a number greater than unity, greater than 1. So that actually shrinks it in the x direction. So you still start at the origin, but what will happen, let's actually just write it out. So what we're looking at here next is the square root of 3 times the square root of x versus the parent function, which is f of x equals the square root of x. So what that means is that when x equals 1, which is here, your value is not 1 anymore, it's this much larger. the square root of 3. So what's going to happen is that this is actually, it moves the y value up, and it moves it up by this ratio. Square root of 3 is 1.732, I think. So I'm trying to make that a little up to 1.7 something. And so this would be 2, so this would be like 3.4 something, and this would be 3, so that's probably somewhere like that. So if I connect these points together, you can see what's happening is it's getting stretched in the y direction, or it's getting pushed in the x direction. Depends how you define it. Okay, so that's the stretching function. So I'll say stretching in the y direction. And then finally we move it up 1 unit. So we just take everything and move it up 1 unit. So it starts here. So when x equals 0, you get 0 plus 1, so you get 1. And then it goes something like that. Okay, what do we got next here? 47. Use the graph of f of x to write an equation for each function whose graph is shown. So what we have is we have this graph. Part A starts at the origin and it goes down. And it goes down through the point 1, 3. And so this over here would be -1, or -3, sorry. And this would be -1, -3. So those are the points. And this is 0. So because the origin or the vertex of the parabola is at 0, there's not any x or y shift. So you'll get f of x is equal to something. You'll get x something. And it's going to be squared. And you can see what we're doing is rotating around the x-axis, so there's going to be a negative sign. And you can also see when x equals 1 that y is -3, so you've got to include a factor of 3 in there. So that is the answer. The negative comes from the fact it's pointing down. The 3 comes from the fact that at x equals 1, y equals 3. So you're -3. So you can put a -3 in here and you can solve for this coefficient. So let's say we were trying to solve for what the coefficient is in front of this expression to reflect whether it's stretched or not. So what you would do is then use 1 point, xy. This is your y value. So you'd have -3 is equal to -a times 1 squared. So you get -3 is equal to -a times 1 divided by -1, you get a is equal to 3, which is the same thing we got here. And the negative sign we assumed from the direction. And then and then part B. So part B looks like this. So it is vertically shifted like that. So we know we have a plus term here, which is 3, because it's shifted from the origin vertically. And if you look at relative to where the vertex is, this is at this point here is 0, 3, and the next point is 1, 7. So the difference in the y direction is 4 units, 3 to 7. Notice over here there's 3 units difference. From when you went to 1, you went down 3. Here we go to 1, we go up 4. So the multiplying factor is going to be 4. It's going to be positive because of the curve is pointing upward. So it's going to be positive 4 times x squared plus 3. And you can check it out. At 0, x equals 0, you get y equals 3. At x equals 1, you get y equals 7. If you get x equals -1, you get y equals 7. So that's definitely the correct answer. Okay. 48 is a cubic function, so we can see the general shape. That's the parent function. We see that it is going this direction, so that it's going to be positive x cubed. So we know it's not it's positive x cubed. There may be some shift in the x direction, and there may be some shift in the y direction, and there may be a coefficient in front of it. Those are the kind of things that we kind of figure out. What's the sign? Well, we figured out the sign because of the way it's going. There is no x shift because this point here where it bends is at the origin, so that's true. And also because of that, there's no shift here, it's just 0. And then we have 2, 2. So a normal cubic function would be, you'd go 1 and 1, and then you go 2, 9. And what we're getting is, when you put in 2, you get 2. So what we need is, let's just think about what will happen here is if I let's think about that. So I mean, you could put a number outside and a number inside. Let's see if either one of those works. So if you had 2 times x cubed, you'd see if I stuck in x equals 2, you get a really big number. So that's not going to work. If I had, but let's say I tried putting a 2 here, but I put an x over 2 there. So you can see when I put x equals 2 in, you'll get 2 divided by 2, which is 1. 1 cubed is 1 times 2 is 2. So that seems to make sense based on that. Now I could multiply this out, so I'll have 2 times x cubed over 2 cubed, which is 8, which is x cubed over 4. Does that still make sense? So again, if I plug in x equals 2 into here, I'll have 2 cubed, which is 8, divided by 2, which is 4, which is 2. 8 divided by 4 is 2. So that seems to work. So either one of these would work. Ultimately, the answer is x cubed over 4 is the equation. And then the last one, you can see, this is part B, it's going the other direction. So I know there's going to be a negative sign here. So I'm going to have y equals negative x, and this could be some constant either in or out. And you know, we have the x shift, but there is no x shift. And we could have a y shift, but there's no y shift. So again, we got to figure out what this is to make this whole thing work out. So what we have is at x equals 1, we get negative 2. Now normally a standard cubic function, you get 1 over 1 or down 1 over 1. So what we need in this case is something. So when x equals 1, we get negative 2. So you might think, okay, well, how about if we just put a negative 2 out there? Is that going to work? So let's try it out. X equals 1, we get 1 cubed. 1 cubed, 1, which is 1. 1 times negative 2 is negative 2. So that does seem to work. in that particular case. So I'd say that's the correct answer. Okay, so that's all there is.